right, so I was asked by a couple people to do either 53, 54, or 55. 54 just seems like a good middle ground because it covers everything from those three problems, and it's also written out the nicest in my notes. So I'm going to do 54 for you and post it up to YouTube. So question 54 reads, the molar solubility of PBr2 at 25 degrees Celsius is 1 times 10 to the negative 2 moles per liter. Wants you to calculate the KSP. Okay, so molar solubility, just as a reminder, is basically the number of moles of any substance, in this case PBr2, that can dissolve per 1 liter of solution. And so the first thing that you should be doing, basically anytime you're given a question, is just writing out the equilibrium expression. So in this case, we're just showing PBr2 dissociating into its component ions, Pb2 plus, and 2Br1 minus, just to balance the equation. PBr2 is our solid, so it would not be in our KSP expression, but Pb2 plus and 2Br minus will be in our equilibrium expression. And then the next thing that you need to notice is that 1 mole of PBr2 is going to produce 1 mole of Pb2 plus, but it's going to produce 2 moles of Br1 minus because of that balanced chemical equation. And so when it comes to considering the concentration of the two ions in solution, Pb2 plus is just still going to be 1.0 times 10 to the negative 2 molar. You could do it in a stoichiometric ratio, but I think you can just think it through yourself over here. But because Br1 minus has a 2 in front of it, I needed to multiply the solubility of PBr2 by 2 to get the concentration of Br minus. And that's where that 2.0 times 10 to the negative 2 molar comes from. So I write out my equilibrium expression, Pb2 plus times the concentration of Br1 minus. Don't forget the square. And then I just plug in my givens up here, and I solve, and I get 4.0 times 10 to the negative 6. Part B wants to know if I have 0.0490 grams of silver iodate, and it dissolves in per liter of solution, and it just wants the KSP again. That's what the solubility product constant is. So if we were in class, I would be like, okay, we have 0.0490 grams of silver iodate. What do you think that you want to do first? And hopefully you would tell me that we need to get to moles of the silver iodate. So I divide by the molar mass, and I get 1.73 times 10 to the negative 4th moles of silver iodate per liter. Because we're just in a single liter solution, that's what solubility is measuring for. And so it's 1.73 times 10 to the negative 4 molar AgIO3. And so then the next thing I do is I do what I did up above, and I write out my equilibrium expression. So I have that silver iodate dissolving into Ag1 plus and IO3 1 minus, and everything's just a 1 to 1 to 1 ratio. And so because it's just a 1 to 1 to 1 ratio, I'm just taking the solubility of AgIO3 and I'm plugging it in for both of these guys' concentrations. So it really is just this squared, and you should get 3.00 times 10 to the negative 8th. Part C is just a little bit different. That was probably the hardest part of this question. It wants me to use the appropriate KSP value from appendice D to calculate the pH of a saturated solution of calcium hydroxide. And so again, writing out the equilibrium equation. So CaOH2 is dissolving into Ca2 plus and 2OH minus. Ca2 plus is just X, but OH minus over here we can see from the coefficients is 2x. And so it's going to be important to plug those values, x and 2x, into my KSP expression. So KSP is 6.5 times 10 to the negative 6, which did it give? No, I had to look it up. So 6.5 times 10 to the negative 6th is equal to x for Ca2 plus and 2x for OH minus, and don't forget to square that. And so then I just went ahead and I did a bunch of fancy math to solve for x. and I found that X was equal to the concentration of Ca2 plus because there's just a 1 out front, which was 0.00176, or I rounded it to 0.012. But for OH, we need to multiply that by 2 because of that coefficient out front. So it ends up being 0.0240 molar. And so to get POH, I took the negative log of this, got 1.629, but the problem asked for pH, so I just took 14, subtracted 1.629 from that, and got 12.37. Hopefully that answers your question for 53 and 55 also, because they're pretty much the same question. So go ahead and try 53 and 55, and those answers are in the back of your textbook, and see if you can get those answers from this guidance, and then just let me know if you're still having a problem. All right, have a nice day, and let me know if there's anything else I can do for you all.